Hello! In the previous video, we linearized an exponential model. We took this expression, used logarithms on both sides, ln y equals ln a e bx. Okay? Then we said we can break this logarithm into the summation of ln a plus ln e bx, and then we said ln y equals ln a, and bx can, from the exponent, can come at the front, and ln e is 1, so we don't write it, and we renamed x to w and ln y to z. Then we used the linear regression expressions to calculate a1 and a0, and then we worked backwards to calculate a and b. So that's how we linearized the exponential model. Okay, now a power model would work pretty much in a similar way. We put logarithms on both sides, ln y equals ln a x b, and then this can be written as ln y equals ln a plus b times ln x. Okay, the only difference now is that this is z, this is w, and the other two terms are a0 and b is a1. Now, for the saturation growth model, okay, we have this addition on the denominator, which is complicating life. If it was on the numerator, we could break this fraction. So why don't we inverse the whole expression? 1 over y will equal b plus x divided a times x. So now I can break this into two parts. So we'll have 1 over y equals b over ax plus x over ax. Okay, so now let's rewrite this as 1 over y equals b over a multiplied by 1 over x plus 1 over a. So what we've done now is that we linearized this expression. So this here is our new w, this is our z, and this will be our a1 and a0. In general, we can linearize any relationship we're given as long as we remember that we want a variable, want the dependent variable to equal a constant times the independent variable plus another constant, which is the expression of a line. So let's assume that we have ln I equals x plus a. Okay, so that's very easy to linearize. This is going to be our new w, and these are going to be our new z. Okay, and obviously in this case a1 is 1. Okay, let's look at another case. We would have minus r equals k times c to the power of n. Okay, so we want to get rid of this power. So we'll have ln minus r equals ln k plus n times ln c. So these are w, these are z, and these are the two constants.